I picked two examples of rationals to add and subtract together based on the fact that these don't have common denominators. That should be the first thing you notice. The denominators are different. And it won't be too hard to settle that up and figure out how to make them the same denominator, but we do have to take that step of making common denominators. So what I do is I always factor any unfactored terms in these things. So we can write delta plus 5 over delta plus 2. There's nothing wrong with that one. And then minus 10 delta plus 23. Okay, nothing to factor out from the top, but the bottom factors nicely into delta plus 3 and delta plus 2. And you can see now what it's missing. This side over here, this side wants another factor of delta plus 3. It already has delta plus 2. But if I could give it another delta plus 3, I'd be good. We'd have common denominators. And the way you do that is this concept of a crazy one that we've talked about in the past. So I'm going to multiply the bottom by delta plus 3. But I don't want to change the value of this fraction. If I were to just multiply it by, let's say, this, okay, I didn't change the top, but I did change the bottom, that fraction has a very different value now. So we don't want to do that. We want to multiply by the same thing on top and bottom. And now what I've drawn in blue, that's just the value 1, right? I don't know what delta is, but I know that delta plus 3 divided by the same thing is equal to 1. So it hasn't changed the value of this expression. Now we go through the multiplication and work this out. So I'm going to have to unfactor the top. What I mean is I'm going to distribute all multiplication terms. So this becomes delta squared plus 8 delta plus 15. That's the left term right here. And then the right one is minus 10 delta minus 23rd. Remember, this minus sign applies to both of these terms individually. So it's minus 10 delta and a minus 23. And then on the bottom, I don't see any need to multiply that out. Generally, you should keep the denominators always factored because you will probably want to check the top and see if that factors as well. You might have something you can cancel out here to make it simpler. So collecting all my common terms, it's a delta squared. Let's see, I have 8 delta and negative 10 delta, so that's going to be negative 2 delta. And then plus 15 minus 23, I think that's a minus 8. Okay, over delta plus 3, delta plus 2. And trying to think, I think that top factors into delta minus 4 and delta plus 2. Double check me there, but that should work out. And the bottom, I still have delta plus 3 and delta plus 2. And you see the advantage of keeping the bottom in factored form, right? Now, there's no extra work. I just have to cross out the delta plus 2's, and I get my final answer, which is delta minus 4 over delta plus 3. Okay? So, next example. Sometimes it's going to look like you're adding a rational to something that's not actually a rational. See this thing? Is that a rational? Well, it is a fraction. It's just a fraction where your denominator is 1, so they didn't write it. So let's rearrange this. Okay, I have negative 4 delta. And remember, this negative sign is multiplied by the 4 delta and the negative 5, so don't lose track of that. It's negative 4 delta plus 5 divided by delta plus 3. And this is a little complicated to say right here, but what I'm going to try to do is put this part in parentheses and say we're adding that thing, right? I'm adding a negative 3 delta, and I'm adding a negative 2. So let's just make this the addition of two fractions, where I have negative 3 delta minus 2 over 1 as my second fraction. And what is the right fraction missing that the left fraction has? Well, it's missing a delta plus 3 factor on the bottom. Once you have a delta plus 3 on the bottom, then we have common denominators. So we have to go through some multiplication to make this work out. You have negative 4 delta plus 5 from the left. And on the right, we have, well, negative 3 delta times delta is negative 3 delta squared. Negative 3 delta times 3 is negative 9 delta. Then we have a negative 2 delta. And then we have a negative 6. I'm just foiling the top of this fraction. And the denominator in both of these is delta plus 3. Okay, delta plus 3. So now we're going to come along and make one common denominator, since they're the same for each fraction. And I'm going to collect these terms together. I only have one delta squared term. It's the negative 3 delta squared. But let's count how many terms we have of regular deltas. Negative 9, negative 2, and negative 4. That makes negative 15, I think. So I have negative 15 delta. And 5 minus 6 is negative 1. Okay, did I do that right? I'm just double checking everything, because if I then get into big X factoring and something doesn't work out, it'll be a little embarrassing. Is this all right? Okay, so let's go ahead. Next, we want to do a big X and just see if this is factorable. I honestly don't know if it is. Let's just check. Negative 3 times negative 1 is 3. Drop down to negative 15. I need two numbers which multiply to 3, but they add up to negative 15. And I'm not pulling any out of my hat here. This is not going to work. So it looks like we have found a prime polynomial. This isn't going anywhere through simplification. That's just what you have.